Hello. This video is one of the videos on operations with functions, and we will talk about division of functions in this one. So division, simply f divided by g, right? F over g of x is equal to f of x divided by g of x. And again, this division will follow kind of same idea as division with just numbers would follow. And then you might notice this here. In the previous 3 videos there was nothing here, but now we have this interesting g of x different than 0. Don't let this confuse you. See the comma here? So it's really not part of the equation, it's simply a restriction. And why do we have a restriction here? Why g of x cannot be equal to 0? Well, since this is division, if g of x is equal to 0, then we would be dividing by 0, and division by 0 is undefined. Let's say if we have 5 divided by 0, if you put that into your calculator and hit enter, you would, depending on which calculator you have, you would get some comments such as undefined or something like that. So this cannot be done. It's undefined. So that's why we have this restriction. So all of this here functions just fine unless the denominator is equal to 0. So we need to avoid cases like that, right? And you will see this kind of restrictions often in textbooks. Don't let them confuse you. It just tells you that certain things that there are certain things that we should be careful about. So now for this kind of problems, there is more than one way to actually do it, approach it. And right now I'm going to show you kind of a simpler case in which top and bottom, numerator and denominator, reduced to some extent. But then in the video after this one, I'll show you a slightly more complicated case that actually requires so-called long division to actually do it. So for example, we have f of x given, and it's equal to x squared minus 5 squared. Conveniently enough, right? And then g of x is equal to x minus 5. So let's do division. So we are asked to actually divide these two functions. So f over g of x is equal to f of x. So I'm just copying the formula over g of x. And then our f of x is given, and it's equal to x squared minus 5 squared. And then g of x is also given, and it's equal to x minus 5 right there. So x minus 5. Now when we are doing division like this, we always need to check, can something divide out? Can it reduce? And in this case, you might recognize that the top here is actually difference of squares. There are two square terms with a minus in between. And difference of squares factors like this. Actually, I'll give you a formula right here. So a squared minus b squared is equal to a minus b times a plus b. Okay, so in our case, x is a, 5 is b, so this is actually x minus 5 and then the second part has a plus, so x plus 5. And then we still have x minus 5 here, x minus 5. Now what we should observe is that since this is multiplication, this can actually divide this one out, right? X minus 5 and x minus 5 divide out. So we will end up with f divided by g of x being equal to just that, x plus 5. X plus 5. The fraction line completely disappears, right? So again, this is division of functions. We have two functions given, and we need to divide this one by that, right? Top divided by the bottom. And then in this case, it reduced, similar to, let's say we had 8 over 2. Well, that's actually 2 times 4 over 2, so the 2 and 2 would go away. So we would end up with 4, right? So this is practically what we did there. We were lucky enough to have something that actually can be factored out and then divided out. So that's it for the division, for this simpler example. If you have questions or comments, please post them below. Like the video, and then yes, of course, subscribe. I would appreciate it. Thank you.